Greetings, Michael Ashman here. As you can see, we're doing this for class 7004, Quantitative Methods in Educational Research. This is Module 4, Discussion 4 video. And while I started on the 5th, I'm now on the 7th for Dr. Bista's class. I was going to originally do a PowerPoint and slide by slide, and I got bored doing it. So I figured if I'm being bored doing it, we'll go for a video showing you how to hit the right buttons on the actual SPSS as we go along with the outputs. Now I've run through this once so I have the outputs ready, but let's show you how it's done. Now rather than read to you, here is this week's discussion, which you can read yourself. I've highlighted what I thought was the more important interesting parts, such as both ANOVA and ANCOVA have more than one independent variable and give you additional information over and above, and are very good when you have two or more independent variables. The factorial ANOVA is good for small numbers. What I found particularly interesting with the ANCOVA is it's great for a situation which I have in green here. For example, imagine we found that boys and girls have differ on math achievements. Now this could of course be for a lot of reasons, such as maybe boys take more math classes than girls, but this allows us to adjust that out and, all things being equal, see what happens. I'll give you a moment to read everything, and of course you can back up the video. This is out of our textbook. Now another thing for the assumptions is, the assumptions for ANOVA are observations are independent, the variations to group are equal or have homogeneity of variance, the dependent variables is normally distributed for each group. Then for ANCOVA, we have 4, which I thought was funny because it labeled it 1, 2, forgot to say 3 and then listed the 4th. This is the actual quote, how they did it. But the first one, of course, is must be independent, needs to be normally distributed, can't be checked, which can be checked with skewness validness, make sure they're not skewed. Homogeneity using the Levene test, and it needs to be a linear relationship between the things. Once again, from our text. Now, step 1, of course, is to load up the file into our friend SPSS, which I have done. I'm using the file that was given on today's thing from the Moodle course to make sure that we're using that one, even though it says a slightly different name, which had, and the ones we've had before have a lot of other ones, but this one had a smaller number of values. Notice the cell code's in there, and there is a small typo in there from the original ones, but we'll be building our own anyway, though I think I have the report run out of the original cell code one to make sure everything was correct, because if I make a typo during this, we don't need that to haunt us later. So let's take this step by step. As the expected output will be APA format, first let's check to make sure that we are actually in APA format. So if you go to View, Edit, and then you go down to Options, over here at Pivot Table, which seems odd, you can go and pick your output format, and I have APA Times Roman 12-point font as my default. That way I know no matter all the stuff I'm doing here, I will get the APA looking charts instead of the standard from the system, which are prettier but do not comply with the APA requirements. Now once again, if you did not follow that, we will go, it is Edit, Options. Now that we know that the APA format is going to be saved in the output form of SPSS, I'm using version 28, which actually comes up later. We're going to go here to Analyze. We're going to go to General Linear Model, Univariate. At this point, I have everything reset, and we'll even double check to make sure I haven't done it because I've been playing with this, and we don't want to have anything kind of strange here. And what we want to do is decide what we're going to do. So I'm going to move Math Achievement to Dependent. After that, I want to move Math Grades 2 levels to Fixed Factor. I also want to move Father's Education Revised 3 levels to Fixed Factor. At this point, I also need to go to Plots because I want to move the Father's grade here to horizontal. Father's Grades Revised, or Education Revised, and I hit Add before I move on. Now I hit Continue. At this point in time, I'm now ready to run my analysis. And I click Continue, or OK. Let's see if I got that right. Make sure before I hit. Let's look at the options. At the options, I want to make sure I have descriptive statistics, estimated effect size, homogeneity test. Leave the rest of the stuff blank. We're going to have a book. Then I will hit OK as well. And I then get the following output, which matches what we should have expected as far as this goes. And I will then cut and paste this into the word processor document we've been dealing with in a few moments to discuss what is important and what's not. So let's take a quick look at that. By video magic, we've now gone to the word processor document where I have put these in right below where we were just looking into this. And this gives me the option of seeing that my variants are what we wanted to do. We were expecting 43 here and 19 down here, and these matches the expected output. What's important here is also I've highlighted the 6 areas of data that would be of interest to us to take a look at to see how these go. And you notice that some college and a BS or more have very similar numbers as far as the means. This shows up later, but it does say draws your attention to it. Moving farther down, we see that we have a significance of 0.036 of math achievement. Now, using the standards, 0.05 or less is significant. That's why this is highlighted to say this is important for us to know. So we do this. Looking at that same information again, once again we've gone back to the math grade and the father's grades, and you see that these have very similar numbers. Now, SPSS less than 28 would list this as zeros. SPA 28 goes less than 001, which is definitely under 5 and significant. And the partial ETA eta squared is 24.3%. Now, if we take the square root of that, that gives us 0.493. And from the text, based on Cohen, we discover that large is above 0.51. Since it's greater than the 0.31, it is therefore a large effect. This should be 3.1? I thought it was 5.1. No, medium is here. Okay. Oh, here we go. 0.31 right here. This is our large line. And now for the R's, it would be the other numbers. So this means this is a large effect. The father's education does matter. And the effect is more important than the significance. It lets us know what to look for, but how much of it does that matter? Now going down here, we'll look at the plots here in a minute, but I'm getting ahead of myself. So we'll go back to SPSS and do that. And I bring that back up. And here we go. My apologies, the plot really did matter at this time, so we'll do that. So we go down here. Notice we have the father's education here going up. And when there's high school or less, it goes like this as far as the failing. Down here, no high school or less, they're not doing well. Dad has a little bit of college and math needs a little bit more. And when Dad has a bachelor's degree or higher, the number of kids who are failing is very low, and the ones that are passing are much higher. The fact that these lines are not parallel is significant. So if you didn't catch it from the numbers, a chart, a graph, a photograph in this case, not in this case, but a photograph says 1,000 words, a picture says 1,000 words. This one says a lot. And as I said right here, obviously Dad at some point had made a difference. Now we'll go to the next 5 steps of what we're doing, and I will get there. This actually concluded the 8.1 problem. That actually happens fairly quickly, and I was trying to keep the base video fairly short. However, we have 8.2 and 8.3, and the post hoc gets a little bit more complicated. Once again, we go back to SPSS, and we have this going on, and then we need to decide what is significant or not. So I have this up, and then once again, I will go to the directions and take a look at how that directs us to go. So moving down on the directions that were given, we also had the area variance of, once again, 0, 5. I've duplicated this, but I wanted to make sure we understood that. Moving down to the next step 6 for this, now we're on 8.22, we're going to make a variable called cell code. It was actually already installed. We'll make cell code 1. I've kept this going because I'm trying to avoid typographical errors like the ones I have here. And we have the logic chart from the book, which is the interaction significant or not? No, then we use one effect at a time. If they are, then we follow this process, which we're going to compute a new variable, run the one-way ANOVA, and then see what happens. So step 7 is we're going to do 8.2 below. So we're going to look for the post hoc thing. Now before we go that, what are the assumptions? First assumption for analysis of covariant and COVA is that the observations must be independent. The second assumption, the dependent variable needs to be normally distributed, which can be checked with the skewness value. Homogeneity needs to pass the Levene's test. And the fourth assumption, there's need to be a linear relationship between the covariance and the dependent variables. Now, we're getting ahead of ourselves. Let's take a look at how we create the chart that you just got a sneak peek of. First, I'm going to go back to our friend, SPSS. Pivot table, look here. And we're good. Now we're going to once again try to put in our cell code new factor. It's already here, but we're going to create our own version to show you how it's created. Now this will get a little bit tedious as far as many input screens, so later on you might want to put the video on fast forward so you can see how I do it at a higher speed. But I'll go through it slow enough so if somebody needs to know what buttons to push, they can keep up. So I'm going to go to transform, compute variable. Now that I have in here, we need to create our target variable, which we're going to call cell code 2 to distinguish it from the one that's already created. And once that's going, we're going to go to type label. And once again, we're going to put in the table of the 6 new, and I'm going to call it 2, to distinguish it from the cell code over here. And I will hit continue. And then I'm going to say I want to put in the first numeric expression, and I want to go to my if there. So I'm going to put together what if-then statements would make this compute. Now what we're going to do here is we need to put in the math grades, and we're going to say the first condition is if this is 0 and father's education revised, and bring that over, is equal to 1, then it will give us an output. So we do this and hit continue. Then afterwards, I'm going to hit OK, I believe. Let me double check. Hit OK. And then I want to go back to transform, compute variable. Once again, we're here. And I'm going to go to numeric expression number 2. At this point, I hit if then, and we have this, except this now changes condition 1, and this is 1. And we hit continue. And then we're going to go here and I'm going to put in 3, oops, get this to do it, 3, hit this condition, in which case now I need to change my conditions again to match up with what we want to do here. And we're going to go back to 0, except this now, 0, and father's education goes to condition 2, and I hit OK. Then condition 4 is going to be 1 and 2, and I do that. Then condition, whoops, that should have been condition 4. So let's go back and make sure we haven't messed up condition 3. Now this needs to be 0 and 2, continue. This needs to become 4, and this becomes 1 and 2. Better. Condition 5 then goes, whoops, come on, numeric expression 5 goes to 0 and 3. And as you can imagine, condition 6 will be 1 and 3. Just get this in here. 6, and I go to if then. Oops, come on, there we go. 1 and 3, and I hit continue. At this point, I believe I'm double. I'm just double checking before we go. We go there, and I hit OK. Change the existing variables, and hopefully we have all those correct. The values did not take, so obviously we need to go back and do that again. So what we do is go transform, compute variables, and I will go through once again 1 if. It would be 0, 1. Now, I'm not going to bore you with all the details here, but we'll go back so you can see that, and we'll get this corrected. It said continue, and it said OK. Change the variable, there we go. And then I would go back and go through these until they're all matching up. To verify I have this, if I go here where it's not taking this is where I put my value 1 and my labels of what's going on. And this would be, the first one would be level 1 grades versus father education, level 1. We add that, and then I do it for 2, so on and so forth, but I'm not going to bore you with that. Now that we've gotten to that part, what we're going to do is we're going to go to Analyze. We're going to go to Compare Means. So we just look for the compare means, there we go. And then we're going to slide over here to one-way ANOVA. We're going to reset to make sure we haven't got anything left over from the prior attempts to play with this. And we're going to go to Contrast and check that everything's there. And what we want to do is we want to make sure that our dependent list has math achievement listed as the dependent variable, and the factor is the one that we know is typed correctly, 6 code, cell code, and get that in there. Once that is in there, then we can click on Contrast, which brings up what we want here, and we're going to click, what did it say, Add, but I think it's now in a different location, this one. So what I need to do is look at those. One moment. Once again, version 20 is slightly different. I go to Contrast to get what I want. Coefficients. I then go to here, and I'm going to put in the numbers I want. And this is where we're going to set up the matrix of coefficients. So initially it is 1 minus 1. So I go 1, add. And this gets to be a bit tedious. Then I go back up here and I type minus 1. And then I'm going to put in 4 zeros in a row. 1, 2, 3, 4. And we hit the mat. We end up with 1 minus 1, 0, 0. The next time we do this, we're going to be moving the 1, 1 over. So we have that. We go continue. Oops, I think I need to go back to that. I think I wanted to go next. Yeah, then I go next. And then coefficient would go, verify that I'm doing this correctly, would be 0, add, 0, add, 1, add, minus 1, add, and then 0, oops, 0, 0. Next, this time I do 4 zeros in a row. 1, 2, 3, 4, 1, negative 1. Oops. Negative 1. Add. Now that I have all 4 sets here, I then can go make sure I have it all right, and I've got it all there. And once we have those, and I hit continue. I click on my options here to make sure I have that right, and I want to make sure that I pick descriptive and homogeneity of variance. Then I hit continue to make sure I get this, otherwise I'm going to get a report. Once I have that, I can hit continue, OK, and it is going to output what you can see here, which would give us the comparison between the father's education at the high school, the performance and the grades. We've also get the significant factors, and you can notice here 0.36 is under 0.5, so this is significant. And then we can look at the rest of this, and I have this all cleaned up with everything highlighted, so one moment. By the magic of video, we have magically popped over here, and what I've done is I took the chart and I squeezed it onto the word processor page because it always wants to go a little farther. And when we look at this, we can see these are the numbers that we care about. The high school is less, and you notice when Dad gets some college, the numbers start matching up, and A's and B's it makes a little bit. But these are the 6 that we care about. Once again, as I pointed out before, on the Levine statistic, the first line is 0.36. On SPSS 28 or later, it gives me extra stuff. But on the original ones, it would just give me this, which is what we needed. And this tells me that we are significant. Then we go down here. So we don't have a violation problem here. Now we're going to go down to looking at the ANOVA assignments before. On SPSS 28 and less than 28, this would be 0.0, but we have significance of 0. That means Levine test, whether we have it, and we can make sure we have no process. This chart here tells us that we had what I inputted, 0 for the Dad at high school, Dad with some college, and here for when Dad has a bachelor's or better. A couple of typos for education level, but that's okay. And then we can go down here on their contrast test. Now when you look here, only this one here that I bolded is under the 0.05, telling us that when Dad has a bachelor's or greater, it makes a big difference. The other ones, while there's an effect, it isn't necessarily significant. So this is where we have the significant and the effect at the same time, which is very good. Excuse me. That is the 8.2. Now comes the 8.3 version of this, and we'll go from there and continue that and show you that in a moment. Hang on a second. Now to take a moment for a flash from the past, this was all pointed out once before. This chart here also says the same thing. Here is very significant. This is almost significant, and obviously the effect is big. And when Dad has no math education, or no high school education, it makes a big difference. And now back to 8.3. The 8.3 question is really, do boys have a higher math achievement than girls if we control for the differences in the number of math courses taken? Good enough question. Does that make a difference? Let's see if it happens. So what we need to do is, this is what the results start coming out to, but what are the steps to get there? So what I'm going to do is first I'm going to go back to our friend SPSS, the A-Team, and we're going to go back to Analyze, General Linear Model, Univariate, and then we're going to hit Reset to make sure we don't carry any factors over from before. And then what we're going to do is we're going to put Math Achievement back in the dependent box. Then we're going to put Gender in the fixed factor box. Fixed factor box. And then we're going to put math courses taken in the fixed factor box. And then math courses taken, Math courses taken go in the covariant box. So we have math achievement and dependent, gender and fixed, and math course taken in covariant. After we've done that, you should have the screen that looks like this. We're then going to go over to model. On model, I need to build custom terms. So I want to put the gender over in the model. I want to put the math courses, and then I want to have the combined. So I click on the top one, hit Shift, this, so I have them both lit, and I drag them over. Now once that is done, then we go make sure I'm on type 3, which I am, include the intercept model where I want again, and get that over there. And then click OK to continue. So I have that done. And then if I hit OK down here, do I need to do anything else before I do this? Nope. I get the following table, which I think I will include below. But as long as we're here, let's take a quick look. Go here. That's not right. I go here, back to this, and this is the table when I clean it up. And if you notice, we have the significant of 0.21 here, where in the original version, I should have had a different number like 0.25 or something like that. This is one of the differences between our friends of 28 or not. So all my output matches 34, 41 like I'm supposed to have. These things add up to 75. Now my significance is once again 0.21. This is good, and I got my intercepted math in there. But after this point, SPSS 28 makes some differences, which we're going to go into a little bit in a moment. But as I come down here, this once again doesn't say 0, this says 001. Then when I go farther down, as far as that goes, and I pull out my statistics, we find out that I end up with gender in here twice. That instead of this being the number I should have gotten, I ended up with this extra one. So we're going to have to figure out what that is. This should have been 005, not 003, and this number changed slightly. Also, so as I go through these different factors, we start saying that we have similar courses, but not exactly the same as far as all the information that we wanted to have in the effect. Numbers. Also, these two numbers came out slightly different than the pre-28 variations. However, when it's all said and done, we still end up with the same conclusions. Originally, this is an 893 and a 292, but once again, these numbers are close enough that when we take out number of courses and adjust for it, the boys and the girls don't, it's not a question of gender, it's a question of dad's education level, not mom's, according to the information we have. If dad has a bachelor's or higher, the kids care more about math. If he doesn't, they don't. And that concludes this very long analysis both ways. I showed you both the analysis and how to get there, including some mistakes. And if you have a version of 28, it looks like mine. Thank you for your time.